So today, again, we're covering the 6.1 material, working with adding and subtracting polynomials together. So before we get into actually adding and subtracting these things, we're going to get a couple definitions down for ourselves. These are some things that we're going to be seeing in this quarter. Some of them we're going to be seeing more regularly in future quarters, but it's worth at least going through and detailing this out for ourselves. So our main definitions that we have, the definition of a polynomial, which is kind of the overarching ones and terminologies that we're going to need throughout this entire chapter. A polynomial is a monomial or two or more monomials combined by addition or subtraction. So the types of polynomials that we have, if you're wondering what a monomial is, we're going to get to that here shortly. So we have three main types of polynomials that we're going to work with. All of these things have specific names to them, but the overarching term is that they are all polynomials. So a monomial is something that has just one term in it. That could be x, that could be 4x, could be negative 1/2 xy, could be 2/3 a squared b squared c, anything like that. But it's just one term. There is no addition or subtraction going on with that at all. For binomials, it's a polynomial with two terms, or two monomials. So that could be written as x plus y, could be x plus 3, could be ab plus, or let's say ab minus x squared y, something like that. So we have two things adding or subtracting together. And a trinomial, following the same pattern, is something that has, it's a polynomial that has three terms, or three monomials being added together, added or subtracted together. So that could be x plus y plus z, could be a minus b plus c, could be m plus n squared minus 2. It's three things adding or subtracting together. Now, we do have terminologies for polynomials that are greater than three terms, but we are not going to be going into those. We are not going to be studying those. We're not going to be seeing those very often. These three are our most common ones that we see, and any polynomial that's larger than three terms we generally just refer to as a polynomial. So all of these are polynomials. These are the three most common forms that we see, and they are going to be having the specific terminology showing up with them. So on the homework, if you see something saying, add the two binomials together, it's the same thing as saying, add these two polynomials together. It's just a more specific terminology that we use. So that's the only difference between saying a binomial versus a polynomial if we have something with two terms in it, or a trinomial or monomial or anything like that. Okay? So just different types and terminology that's going on that will appear with these. So another one that we have is the degree of a term. So our definition for the degree of a term is the sum of the exponents of its variables. So I'm going to bring us down here to, we'll get to some actual adding and subtracting examples that we have here. But I'm going to work with specifically the degree of a term. So looking at our first example, we're looking at the first term, which is negative 4n cubed. The degree of this term is the sum of the exponents of its variables. So the only variable that I have on this first term is n, and its exponent is 3. So the degree of this first term is 3. Similar with the second one, how many variables do I have here? I just have an n. And what is the sum of the exponents of this term's variables? Well, it's just going to be 3 also. So what is the degree of this term? It's also 3. Looking at example 2, if we look at the first term in this binomial, two terms here, binomial, if I was being asked what is the degree of this first term, I notice I have an x and I have a y within that. And again, the degree of a term is the sum of the exponents of its variables. So for this first term here, I have an x squared, and I have a y. That y is implied to have an invisible 1 as the exponent. So the sum of the exponents of the variables in this term is going to be 3, which means that the degree of this term is 3. If we take a look at this 7y, this monomial that we have right here, what's the degree of this term? The only variable is y. It is implied that its exponent is that invisible 1 up there, so the degree of this term is just going to be 1. Got one more example here. If we look down at example 4, we have this term 10a to the 6th, b to the 3rd. We're being asked, what is the degree of this first term here? So I have an a as a variable, and I have b as a variable. And again, the degree of a term is the sum of the exponents of its variables. So the exponent attached to the a is a 6, the exponent attached to a b is a 3. The sum of those variables, or the sum of those exponents, is going to be 9, which means the degree of this term is 9. Similarly, with our second term that we have a b to the 3rd power, a c to the 1st power. The degree of this term is the sum of the exponents, so the degree of this particular term is going to be 4. So that's how you would go through and determine the degree of a term, and our process for that. Again, it would have to be the polynomial, the monomials, or anything like that. It would have to be given for you, or given to you for you to be able to solve those, I should say. So a couple other parts we want to go through with this, kind of expanding from the degree of a term. The degree of a constant, meaning any just number, like the number 2, the number 3, the number -8 here. The degree of a constant is just 0. Again, because the degree of a term is the sum of the exponents of its variables. If there is no variable, meaning I have a constant term, then it's going to have a degree of 0, because there is no variable, there is no exponent attached to that then. Now the last one that we can be asked about is determining what is the degree of a polynomial. So it looks at everything within the polynomial that we are working with. If I have a binomial, it's looking at the 2 terms that it has. I'm looking at a trinomial, it's looking at all 3 terms that it has. And if we're going to determine the degree of the polynomial, that degree of the polynomial is determined by the highest degree of all of its terms. So what you would do is you would go into whatever polynomial you've been given, and you say, what is the degree of this first term, second term, and third term? The degree of this entire polynomial is then going to be the highest degree of all of its terms. So looking at our example that we have here, this first trinomial in example 3, the degree of this first term is 2. The degree of this second term is 1. It's got that invisible 1 hanging out up there. And the degree of this third term, it's just a constant, means its degree is 0. So what is the degree of this whole polynomial that I have right here? Again, it's the highest degree of all of its terms. The highest degree was 2. So what is the degree of this polynomial going to be? It's just going to be 2. So we can think of it as, what's the degree of a polynomial? Find the degree of every term, and then the largest degree, that's the degree of the polynomial. I think there's a couple of questions on the homework that ask us to do some stuff with that. It's not a particularly common question that shows up on a lot of stuff we work with in the future. There's a few instances where it's very handy to know this, but it's not one of those ones where if you don't know it, all of math falls apart and makes no sense or anything that particularly extreme. It's really good to know, but don't beat yourself up if it's taking a bit longer to get it nailed down and we're maybe struggling with just a little bit on that front. This is also generally something I do not put on tests. So you might have one question about this. It's a big maybe, but not something I generally test people on. So those are our definitions of some terminology that we're going to be seeing throughout this section and probably the rest of this chapter as well. Let's start getting into the main part of this section, which is how do we add and subtract polynomials together. And the central part that's going to make all of this work is the general idea of combining like terms. This is the thing that's going to make all of this work for us. So what this means is when we are adding and subtracting polynomials together and we are combining like terms, it means all of the variables and their exponents in a term must be identical with one another to be able to add or subtract coefficients together. That is an extraordinarily strict and demanding statement. They must be identical with one another. If there is any difference in any way, shape, or form, I cannot add and subtract two terms together. They absolutely must stay separate. So if both terms have an A and a B in them, great, they've got the variables that are the same. If the exponents are different for each of those variables and each of those terms, then I cannot add or subtract the coefficients together. It is an extraordinarily strict rule. The variables and exponents must be identical with one another. There is no room for any exception on that. If they're not identical, you cannot combine like terms, and you absolutely must leave your answer separated out as different terms. If you try and combine them together, you are going to get a wrong answer. You cannot do that if the variables and exponents are different between two terms. I have docked a lot of points from people on tests. I've docked a lot of points on homeworks because people do not keep track of this rule for themselves. It's very, very strict on that front. It must be identical with one another. Another part that comes into play with this when we're adding and subtracting polynomials together, and we'll get to it with our examples, is remember to distribute signs correctly. So if I have, taking a look at this, and we'll get into it here, looking at example 2, I have a binomial, two terms, minus a binomial, another two terms, and I have a negative sign out front. Make sure you are correctly distributing this negative sign to every term in the second binomial. If you are not, you are going to get wrong answers. A lot of people just quickly go, oh, it distributes through to there, and then it's going to still be plus 4 what? No, wrong, incorrect. So make sure you are going through and distributing signs correctly. And we'll go through these examples here that should help out with that. And then this is an optional step that you can do, but a lot of people like to reorder the terms before adding them together to keep work organized. I'll show you guys what I mean by that. It's just an organizational tool that some people like to use and some people don't like to use when they get to the combining like terms step, a lot of these. And again, it's optional. If you would like to do it, you are welcome to. If you don't really want to do it, that's fine also. Whatever helps keep your work organized. We're going to see in a couple of these, and I think it's going to become apparent in, I think it's 6.2, maybe it's 6.3, that doing operations with polynomials can either be very straightforward and fairly easy, or it can become very difficult and an absolute mess if you do not keep your work and what you are doing organized in some way, shape, or form for yourself. And again, there's lots of ways to do that. I'm not going to be grading you on you're organizing your work differently than me, but getting the exact same answer. No, organize it whatever makes sense to you. Okay. So we're going to take a look at these 4 examples for combining the following polynomials together. Again, adding and subtracting polynomials. So these are the 4 that we're going to take a look at. Pretend we don't have the answers already. We'll jump over to our Blackboard and take a look at those over there and actually go through these things. Okay. So our first example that we have is, what we have here? Sorry, bring it up on my other screen so I can make sure I'm giving you guys accurate and correct numbers to work with. There we go. Okay, so our first example, we are working with negative 4n cubed plus 9n cubed. Let's make that a better 3. There we go. Okay, so again, we are told to combine the following polynomials together. So I'm looking at these and I'm saying, okay, can I add these things together? I have a term at the front, term at the back, and they're being added. Are the variables the same? And are the exponents attached to the variables in each term identical with one another? So looking at the first term, I have an n cubed. The second term has n cubed. So the variables are the same and the exponents are the same also, which means I can add the coefficients together, the numbers out front. So negative 4 plus 9, that's going to give me a positive 5. And the n cubes are going to stay the exact same. The variable parts of these terms are going to stay the exact same. All that's adding together are the coefficients. So with this example, we had n cubed showing up. The n cubed is going to stay there the entire way through the problem. All that's going to change when we're adding and subtracting is just the coefficients. They mean the numbers out front, not the exponents, not the variables. So taking a look at our second example, we have the binomial 3x squared y minus 7y minus the binomial 2x squared y plus 4y. So again, trying to get our terminology down, we have a binomial here. It has two terms, the first one minus the second one. And we have a binomial over here as well. We have that 2x squared y plus 4y squared. We have two binomials subtracting together. Okay. So now I want to say, okay, I've been given this. I want to get everything outside of these parentheses so I can actually add or subtract values together. The first binomial doesn't have anything in front of it, meaning there's nothing out front here that's going to change its value at all. So I'm just going to rewrite that down below without the parentheses in there. I'm just going to have 3x squared y minus 7y. Whoops. Second binomial, I made a mistake there. We should have a negative 2x squared y in there. Now it's all written in correctly. Okay. Our second binomial has this negative sign out front, which means this negative sign needs to distribute through to every term inside here. And what that's going to do, you can think of that negative as being an invisible negative 1. So negative 1 times negative 2x squared y, well, all that's going to do is just going to change the sign from a negative to a positive. So we get plus 2x squared y. And then that negative times the positive 4y, that positive is going to become a negative, so I'm going to have minus 4y showing up there. So I have everything written outside of parentheses. Parentheses are gone. Now I can add or subtract these things together. Now before I do that, I do want to show you guys what I mean by reordering the terms before adding or subtracting them together. So again, we're looking to combine like terms. So I'm looking to see, okay, I want to combine everything that has the exact same variables and the exact same exponents together. So as I'm looking through this, I'm seeing I have an x squared y term here and here. So in our next line of work, if you would like to, before we add them together, let's rewrite this so I have those common terms, or those like terms, written next to each other. When you are doing this, make sure you keep the signs out front of those terms as well. And then we're seeing, okay, I've got a y term and I've got a y term over here also. So let's rewrite those to be next to each other. Again, keep the sign, the coefficient, and the variable together. But now I'm seeing, okay, so here's those like terms, here's these like terms, and now I can combine them together. When we do that, again, I have an x squared y and an x squared y. Those can combine. The coefficients are the only thing that's going to be changing. So 3 plus 2, that's going to give me 5. Keep the variable part of these terms the exact same. So keep that x squared y in there. With the y terms, I have negative 7 minus 4. That's going to give me negative 11y. And we're good to go. So this line right in here, starting the third line where we rewrote everything with the similar terms next to each other, it's optional. You do not need to do this step, but if this helps you keep your work organized and see what are the like terms that we can combine together, then absolutely do that. Nothing wrong with you doing that on your homework, nothing wrong with you doing that on the test. If that helps make these problems easier for you, for how to combine like terms, 100% use it. Nothing wrong with that. Move us over here. We'll go and take a look at example 3. So example 3, make sure I can actually write this thing out correctly this time. There, and then minus 8. Okay, so we've got m squared plus 5 minus 2. Okay. Okay, there we go. So we have this statement that we're starting with here. So our first term is a trinomial. It has 3 terms in it. Our second parentheses is also a trinomial. It has 3 terms in it. And our last set of parentheses is a binomial. It only has 2 terms in it. So we have a trinomial plus a trinomial minus a binomial. So again, just trying to get that terminology down for our types of polynomials is all. What each of these things are is a monomial, binomial, trinomial, anything like that, is not actually going to affect how we work with these things. I just want to get us some practice in and seeing, here's what a trinomial likes, here's what a binomial looks like, and so on and so forth. So just like we did with our previous example, we want to get everything outside of the parentheses so that way we can add or subtract everything together. So our first trinomial, our first set of parentheses, there's nothing out front of it, so I'm just going to bring those terms down as they are. So m squared plus 5m minus 2. Second trinomial, I have plus 6m squared minus m plus 3. Again, we could think of there being an invisible 1 out front there. 1 times anything is just going to be itself. So that's going to come down exactly as it is. And then for our last set of parentheses, we have that negative sign up front. Again, it's implied that there is a negative, you can think of it as there being a negative 1 there. So this negative 1, kind of say air quotes around that, distributes through to everything inside of that polynomial. So negative 1 times 2m squared, that's going to be a minus 2m squared. And then negative 1 times negative 8, that's going to be a positive 8. So now I have everything written out in the open. All the parentheses are gone. Now I'm going to look to combine like terms. And again, I'm going to go through and show you guys working through this thing where we are reordering the terms before we add them together. Again, it's optional if you want to or not. So I'm looking at this and I'm seeing, okay, I've got an m squared term. I have another m squared term, I have another m squared term. So I'm going to write those just together in my next line of work. Yes, so -1, we can think of there being if there's just a negative sign, you can think of that as being a -1 out front. Message in the chat with that, yes. So I have the m squareds all written together. Now I'm going to look at, okay, where are my m terms? I've got an m term there, I have an m term there, and nowhere else. So I'm just going to rewrite those coefficient and sign all together. And last but not least, looking at my constants, I have a -2, I have a +3, and I have a +8. So I'm going to write those together. So now all of my like terms are written right next to each other, and it makes it, I think, a little bit easier to combine these things together instead of having to go all over this big mess of stuff that we have here in our second line of work. So combining like terms, m squared plus 6m squared minus 2m squared. 1 plus 6 is going to give me 7. 7 minus 2 is going to give me 5, so I get 5m squared for my m squared terms. 5m minus m, that's going to give me a positive 4m. And then with my constants, -2 plus 3 plus 8, -2 plus 3 is going to give me a positive 1. Positive 1 plus 8 is going to give me 9. I cannot combine any other terms together. I have m's showing up with 2 of my answers here, but one of them is an m squared, the other is m to the first power. So the variables are the same, yes. Their exponents are not, which means they are not identical to one another, which means I cannot add or subtract them together in any way, shape, or form beyond this. I am now done. Cannot do anything else from here. And again, a lot of people fall into the pitfall of, well, a whole bunch of these things have m's in them, so I can add all of the m's together. No, you cannot. You can add the m squareds together. You can add the m to the first together, or just the m values together, but you cannot combine the m squareds and the m terms. Again, the variables and their exponents must be identical to combine like terms together. If they are not identical, you cannot do anything with them. They have to stay separated. No choice on that. So take a look at our fourth example that we have here. I'm kind of illustrating how gross these things can get with the exponents at least, but it's not going to change with how we work with them. So we're starting with 10a to the 6th b to the 3rd plus b to the 3rd c minus the binomial 3a to the 6th b to the 3rd plus 8 b cubed c. Okay. So just like our previous examples, we want to get everything outside of the parentheses so that way we can start adding and subtracting like terms together. So our first binomial we have right here, there's just an invisible 1 out front, so nothing is going to change with this. So we're just going to rewrite it below. And with the second one, we have that negative sign. Again, you can think of that as being a -1, but that negative is going to go through to every term in this binomial. And all it's going to do is change the sign. So that positive 3a to the 6th b cubed is now going to become negative 3a to the 6th b cubed. This positive 8b cubed c is now going to be a negative 8b cubed c. C, not 0. So now again, if you wanted to, it's an option. I'm just detailing it out this way. It's your choice if you want to do this or not. Let's rewrite this thing so our like terms are next to each other. So I have an a to the 6th b cubed. I have another a to the 6th b cubed term over here. So let's just rewrite those next to each other. Again, make sure you're keeping the coefficient, the sign, and the variables the same in this rewriting part. Then I have a b cubed c, and I have a b cubed c together, or within this. So now I have like terms written next to each other. Again, it's optional if you want to do this step, but I think it's helpful to keep our work organized. And now I can combine like terms together. So I have the a to the 6th b cubed terms at the very start. I'm the exact same. The variables and exponents are the same with one another. They're identical, so I can add the coefficients together. So I've got 10 minus 3. That's going to give me 7. And then leave the variable part the exact same. I'm looking at b cubed c minus 8b cubed c. The variables and their exponents are identical to one another. Great. So I can add or subtract the coefficients together. So I have 1 b cubed c minus 8 b cubed c. So 1 minus 8, that's going to give me negative 7. And then we keep the b cubed c there at the end. Now, if we're looking at this, some people in the past have said, well, okay, so our first term here has a b cubed in it. Our second term also has a b cubed in it, so I can add these things together. And no, we cannot. The first term and second term, they do both have a b cubed c. I agree with that. However, we need to make sure that all of the variables and their exponents are identical. The first term has an a to the 6th in it. The second term has a c in it. So part of the variables and exponents are identical to one another, but not all of them, which means I can't do anything else to combine these terms together. We can't do a partial, well, it's got a b cubed, so I could add maybe part of the first 7 and the second 7 together. You know, can't do any of that. If the variables and their exponents are not identical to one another, we cannot add or subtract these things together in any way, shape, or form. And with that being the case, we can't do anything else from here. We are done. I just wanted to mention that part because that is a very, very common pitfall that people fall into with these of they see something that's similar, which means we can obviously combine everything together. And no, we cannot. All of the variables and all of the variables' exponents must be identical to add anything together. If they are not, you cannot do anything with those. Okay. So I'm seeing some come up in chat. What about negative 8? So the negative 8 that showed up in here was negative 8 b cubed c. This here was a positive invisible 1 b cubed c. b cubed c, b cubed c, I can combine these together to get that negative 7 b cubed c. So these are our main 4 examples with going through and adding or subtracting polynomials together. I am going to jump us back to our notes because we do have another part with 6.1 touch base on. This thing is going to quit lagging on me, that'd be fantastic. Just move us back over to here. All right, so we'll jump us back over to our notes. So that was working with adding and subtracting polynomials together. Again, our 4 examples that we went through. So the next part that we have is evaluating polynomials. So how we evaluate these things, what's our process for it? So when we've been given a polynomial and asked to evaluate it, we are going to plug in the given values to their respective variables and then simplify using PEMDAS. So what these are going to look like, you will be given a polynomial in some way, shape, or form. It will have 1 variable, 2 variables, 5 variables, 10 variables, some number of variables in it. You will then be told to evaluate this polynomial for, and then each variable will be assigned a value. All we are doing is we're taking that value and we're going to plug the given value in to their respective variables in the problem. And then we are just going to simplify using PEMDAS, our order of operations. So our first example, and we'll go through and actually write this in and work this out on the blackboard. So the first example, we have been given a polynomial. It's got the variable n showing up in it. So we have this equation, or this expression, and we're evaluating it for n is equal to 2. So I'm plugging 2 into each of these parts and then simplifying. For our second example, and again, we're going to go through both of these, I have x's and I have y's showing up with this. We are told to evaluate this expression for when x equals 3 and y equals 10. So wherever there's an x, I'm plugging in that 3. Wherever there's a y, I am plugging in that 10. And then I simplify that down and I'll get my answer. Assume we don't know what the answer is just yet. But I'm going to go through what this looks like, how we write this out for ourselves right now. So these are the 2 examples that I'm referencing. We're going to jump on over to the whiteboard. Oops. There we go. Okay, so we were given negative 4n cubed plus 9n squared plus 10n. We were told to evaluate this thing for n equals 2. Okay, so what we are doing, again, I made this as abundantly clear as I possibly can. We are plugging 2 in for n wherever it shows up in this problem, this expression. Now, when you are doing this, I highly, 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 highly recommend to everyone, when you are plugging these things in, or substitute them in inside of parentheses. This becomes abundantly clear when we have especially negatives showing up with this. So I have negative 4 times 2 to the 3rd power plus 9 times 2 to the 2nd power plus 10 times 2. So again, when you do this, here's our 2, here's our n. Wherever an n shows up, put inside of parentheses that positive 2. Again, inside of parentheses. And this becomes abundantly clear when we have negative signs showing up in this, because negatives have special properties attached to them because they change signs potentially. So make sure whatever you are plugging in is written in your first line of work inside of parentheses. I cannot emphasize that enough. I've seen too many people lose points because they just write in 2 or put a little dot 2 in there. Put it in parentheses. So once we have everything plugged in, now we're just following our order of operations. We're just following PEMDAS now. So the exponents are not in parentheses because we are raising that n value to the second power. And the n value, when we substitute it in, is 2. So I'm raising 2 to the third power, 2 to the second power. So I'm substituting and changing my n from being a variable into a number. And that's why the exponents are going to be staying outside of that, because I'm changing the variable itself, not the exponent. So as we're going through this, again, PEMDAS, our order of operations, if we need a quick refresher on that, again, parentheses first, then exponents. I cannot do anything inside the parentheses, it's just the number 2. Exponents. 2 to the third power, that's going to give me 8. Better 8. I have plus 9 to the second power, it's going to give me, or 9 times 2 to the second power. 2 to the second power is 4. That there. Exponents are done. Multiplication, division. Negative 4 times 8, it's going to be negative 32. 9 times 4 is going to give me 36. 10 times 2 is going to give me 20. Multiplication, division is done. Addition, subtraction. Negative 32 plus 36 is going to give me a positive 4. Positive 4 plus 20 is going to give me 24. Can't do anything else from there. We have our answer there. So evaluating is just plugging things in and then simplifying. So move us over here and we'll go through number 2. So I'm going to do a slight modification to number 2 because I want to emphasize having a negative written in there. So I'm going to deviate from what is originally written down, for example, because I do want to hit home the rationale behind why we use parentheses in here. We have x is equal to 3. I'm going to use y equals, I'm going to use negative 10. So again, deviating from what the notes say, but I'm using this to emphasize why we want to have everything that we plug in inside of parentheses. So our first step, exact same as what we did in the previous example. I'm just substituting in 3 for x and negative 10 in for y. So instead of x to the second power, x is now that 3. So we're plugging that in there. Y is no longer y, it's now negative 10. Minus 11 instead of y, get the negative 10 in there. So this is the correct way of how we want to go about this. And why we want to write it in like that, put it in here. Versus by comparison, if you don't do that, here's what I've seen happen quite a bit for people. Now, if you're looking at the second part that we have over here, if you aren't making it abundantly clear for yourself that there's a dot there implying multiplication, I've seen a lot of people say, okay, well, it's 5 times 3 to the second power minus 10 minus 11 minus 10. Again, this little dot in here kind of gets lost in translation of, well, I should actually be multiplying that negative 11 and negative 10 together, but if we don't write it with parentheses, we may get mixed up with saying, oh, it's just going to be a negative 11 minus 10. This version of it over here is not very well organized, and this is where errors can show up. This is where errors can show up. So again, when you are substituting things in, do not just write the number in. Put it in inside of parentheses. It makes it abundantly clear what you are doing and where you are plugging those in. I also think it makes it a lot easier to tell if we're going to be having positives or negatives in there and what we're doing with that. Okay. So if you do not want to plug it in inside of parentheses, you theoretically can still get the exact same answer. But I have seen a significantly larger number of people screw this up for themselves because they do not do that or put the parentheses in there at all. But now if we are starting from here, order of operations following PEMDAS. You can write it out for yourself if you need to. Exponents first. 3 to the second power is 9. Then comes multiplication. 5 times 9 is going to give me 45. 45 times negative 10 is going to give me negative 450. Negative 11 times negative 10 is going to give me positive 110. Then negative 450 plus 110 is going to give me, if my mental math is correct, I think that's going to be a negative 340. And again, this differs from what was originally written in the notes because I did change the problem a little bit. But this is how we go through and we evaluate polynomials. We must be given an expression and we must be told what we are evaluating it for. So this information has to be provided for you in the problem. If it's not provided for you, it is entirely impossible for you guys to go through and solve and evaluate this thing. It's impossible at that point. So this is everything that we have for the the 6.1 material. We'll end our recording here.